In this video, we're going to have two objectives. First objective is we are going to determine whether or not a relation defined by an equation is a function. So if you are given an equation, does that equation represent a function or not? Second, we are going to find the domain of a relation that is defined by an equation. So if we are given an equation, can we find its domain? In other words, what are the possible x values that will give an output for that equation? Here are the guidelines for both of these objectives. We will actually start with finding the domain. When you are finding the domain of a relation whose equation is given, there are really two things that we are going to look for. There are more things in more complicated equations. You might need to look for more things, but for now we will focus on these two things. First of all, we need to exclude from the domain any values that make the denominator equal to 0. Remember, one thing that is true is that you cannot divide by 0. 1 divided by 0 does not make sense. If you put it in your calculator, you will receive an error. So you cannot divide by 0. So if you have a function that has a fraction, make sure you have to get rid of any x values that would make the bottom of that fraction equal to 0. Those x values will not have a proper output. There will be no y value associated with that x value. Second, exclude from the domain any values that result in a negative number under a square root or any even root. So there's a square root. You could also have a fourth root, a sixth root, an eighth root, etc., etc. For the most part, we will be dealing with square roots, just so you know. What is the reason for this? Well, if we are dealing with real valued functions, where the input and the output are only real numbers, the square root of a negative number does not make sense. There is no real number where that is equal to the square root of -4, because there is no real number that when you multiply it by itself, you will get -4, because 2 times 2 is +4, and -2 times -2 is also +4, right? So you can never have a negative number under a square root. It doesn't make sense. And so if we have a square root in our equation, we have to make sure that we only input numbers for our x values that will result in our square root having only non-negative inputs. You can have 0 as underneath a square root, because the square root of 0 is 0. You just cannot have negative numbers. So either positive, or you need either positive numbers under the square root or 0. Now, if you are trying to decide whether or not an equation is a function, first step is to solve for y. And then you need to decide if it is possible to have two different y values for the same x value. If you can have two different y values for the same x value, it is not a function. Remember, the way we define a function, every input has at most one output. It can have 0 or either 0 outputs or 1 output. So if that is not the case, if every x value has only 1 or less outputs, then it is a function. So again, if it is possible to have two different y values for the same x value, then it is not a function. You can't have two different outputs for the same input. And if that's not the case, then it must be a function. All right, let's just, again, go over some examples to explain these concepts. All right. For each of these problems, we're going to do two things. We're going to determine whether or not the given relation defines y as a function of x, and then we're going to state the domain of the relation. Okay, in this case, the first step is always to solve for y, but this is already solved for y. Y is by itself on the left-hand side. So now we're going to look at this and decide, for every x value, is it possible that I plug in some number for x and I get two different numbers for y? Well, if you think about it, that's not going to be possible. If I do 2 times 3 minus 4, I'm going to get exactly one value, right? 2 times 3 is 6, minus 4 is 2. If I do negative 5, that'd be 2 times negative 5 is negative 10, minus 4 is negative 14. You will, no matter what value I plug in for x, I'm going to get exactly one value for y. So this is a function. Next, I have to decide what the domain is. And the real trick to this is just, do I have any fractions, or do I have any square roots or other even roots? In this case, I don't have any fractions and I don't have any square roots, so there's no x values that I really need to avoid. So its domain is really the set of all real numbers, which in interval notation we would write like this. So all the numbers in between negative infinity and infinity, that would be all real numbers. All right, let's go ahead and do another example. What if I have y squared equals x plus 1? Now in this case, y is not, actually, I have not solved for y yet. Y is not really by itself because y has an exponent. So I need to get rid of that exponent. Now how do I get rid of an exponent of 2? Is I take the square root of both sides. Now one thing that is important, if you are ever getting rid, if you are ever taking the square root of both sides of an equation, well, on the left-hand side, these are really going to cancel out. The square root sign and the square, these are inverse functions. They cancel each other out. We'll be left with y. But on the right-hand side, you have to be careful. Whenever we take a square root, when we're solving an equation, we have to put a plus or minus in front of it. Okay? The reason why is simple. I'll give you a little bit simpler example. Why is this true? Let's say we have y squared equals 4, and I want to figure out what the values are for this equation. I take the square root of both sides. If I don't write down my plus, I'm sorry, I did a small mistake. Let me put the 4 there. When I take the square root of 4, I get 2. If I don't do that plus or minus, though, I'm actually missing one important value, because y equals 2 is not the only possibility here. Sure, 2 squared is equal to 4. That is correct. But there's another number when I square it that will be equal to 4. Can you think of what that might be? If you thought to yourself, well, negative 2 times negative 2 is also equal to 4, you see that if we don't put that plus or minus there, we actually miss one of our answers. So for that reason, we need to put plus or minus here, which means that my answers are y equals plus or minus 2, which is really the same as saying either y equals 2 or y equals negative 2. The plus over the minus sign, we call that plus or minus, and it means that both the positive and negative version of that number are solutions. So we have y equals, in this case, plus or minus the square root of x plus 1. All right. Now again, now that we get here, is it possible to have one x value that gives you 2 different y values? Going along with our example here on the right, let's just plug in x equals 3. If I plug in x equals 3, I get y could be equal to plus or minus the square root of 4. And what's the square root of 4? Well, the square root of 4 is positive 2. So notice that when I plug in my x equals 3, I get two possible values for y. Y could either be equal to 2 or y could be equal to negative 2. And if we go back to our original equation, this should make sense. Let's see, what's positive 2 squared is 4. 3 plus 1 is 4. That is true. So the point 3, 2 is a solution to this equation. If I plug in negative 2 for y, negative 2 squared is positive 4, and 3 plus 1 is also equal to 4. And so 3, 2, and 3, negative 2 are both solutions to this equation. For that reason, this is not a function. Now we're going to find the domain. We actually should look at this. We should look at this and notice that we have a square root, and we need x plus 1 to be a positive number, right? Or it needs to be non-negative. Whatever's underneath that square root sign needs to be greater than or equal to 0. So the easiest way to figure this out is to do this. I just make an equation. I need x, what's underneath that square root sign is x plus 1. I need x plus 1 to be greater than or equal to 0. And then I'm going to solve this inequality. And so I just subtract 1 from both sides. These cancel out. And that means x has to be greater than or equal to negative 1. So on the number line, the possible x values that will have an output will be all the numbers that are greater than or equal to negative 1. So that'll be all of these numbers here. Again, I'm just going to put negative infinity and positive infinity here. And that helps me figure out, so how do I express this in interval notation? Well, it's all the numbers in between negative 1 and infinity. All right, let's do a couple more examples. All right, so let's take a look at this. First, let's determine whether or not the relation given is a function. The way I would think about this is like this. If I plug in for the top x plus 4, I'm only going to get one number, one possible number on the top, right, in my numerator. If I plug in a number in the bottom, again, when I square that number and I subtract 2x minus 3, it's impossible that I could get two different numbers for the same x value, right? So I'm going to get one possible number on the top, a different number potentially on the bottom, but there's only going to be one number on the top and a unique number on the bottom. And if I divide a number by another number, I'll get exactly one possible y value, right? No matter what I plug in, I'm going to get exactly one unique output. Let's just do a quick example just so we can see that's true. Let's try x equals 0. And that'll be 0 plus 4 divided by 0 squared minus 2 times 0 minus 3. This ends up being 4 divided by negative 3. Right? And if you're not sure, just plug in a couple numbers so you get a feel of it. Let's just do x equals 1. That'd be 1 plus 4 on top divided by 1 squared minus 2 times 1 minus 3. That's going to be 5 on top. This would be 1 minus 2 minus 3, and that's going to be negative 4. If you play around with it, you'll get this sense that if you want to try a couple, you'll start to realize that, yeah, there's just no way that I can get two different y values outputs for the same input. So this is a function. Now, to find the domain, again, we have to be careful, and we have to make sure, in this case, we don't have any square root, but what we do have is a fraction. And so we cannot have x squared minus 2x minus 3 equal to 0. So we need x squared minus 2x minus 3 cannot be equal to 0. Now we just need to solve for this equation. In other words, we need to figure out when does x squared minus 2x minus 3, when is that equal to 0? And then we just avoid whatever those x values are. Now to solve for this, we are solving a quadratic. The easiest way to solve quadratics is to test if maybe it factors. So I'm going to try to think, is there two numbers that multiply to get negative 3 and add to get negative 2? And I guess that would be x minus 3 and x plus 1. Right? And that's factored out. And so that means that either x minus 3 is equal to 0 or x plus 1 is equal to 0. I'm going to solve both of these equations. And so I know that if either x equals 3 or x equals 1, then this will not be a function, right? So I have to, my domain will really be the set of all x such that x is not equal to, and by the way, I made a small mistake. This should be a negative 1 here. It cannot be equal to negative 1. And x cannot be equal to 3. That's how we would express this in set notation. Now I'll show you, to do the interval notation is a little bit complicated, but I'll show you what I think is the easiest way to do it. Again, I like to start with the number line. And I'm just going to put the important numbers, which are negative 3 and positive, negative 1 and positive 3. And if I shade in all of the numbers except for negative 1 and positive 3, I'm going to just put a circle here and a circle here. And it'll basically be all of these numbers to the left of negative 1, all of the numbers in between negative 1 and 3, and all the numbers in between 3 and infinity. Now my suggestion is, again, put our negative infinity on the left and my positive infinity on the right. And we're going to use this to make our interval notation. The left-hand side, that's all the numbers in between negative 1, in between negative infinity and negative 1. So we put this. Then we put the union notation right there. And so we put that together with, and what's the next part of this number line? It's in between -1 and 3. And then I have to get the right-hand side, so I put another union. And the right-hand side is all the numbers between 3 and infinity. Again, using the number line, I do think makes interval notation easier to use. And notice that I am using curved brackets at -1 and 3 because we don't want to include -1 and 3. Those are the numbers we are trying to avoid. So that is my domain. So this is a function, and here is my domain. All right, we're going to do 2 more. Y equals the square root of 2x minus 1. All right, is this a function? Let's find out. Again, I would just plug in a couple numbers. If I plug in x equals 0, I'm going to get the square root of 2 times 0 minus 1. That's the square root of -1. Now, this doesn't have an output because this doesn't make sense. But that doesn't mean it's not a function. Okay? That means that 0 will not be part of my domain. Okay, that's not a possible input. So maybe I'll try a bigger number. Let's do x equals 2. That'll be 2 times 2 minus 1. And so that'll be the square root of 3. Now the square root of 3, when we use the square root function, there's one output. We just choose what is the positive number that when we multiply by itself is equal to 3. It's some number like 1.7 something would be my guess, right? So there's only one output. If I do x equals 3, for example, that'll be 2 times 3 minus 1. That's going to be the square root of 5. Again, there's exactly one positive number that you can multiply by itself to get 5. In general, if I do 2 times a number minus 1, I'm going to get exactly one number. And when I take the square root of a number, there is only one possible number that can be the square root. So I am feeling satisfied that this is a function. To find the domain, again, I have to make sure that whatever is underneath, we have a square root here. So we always look for fractions and square roots. And I want to make sure that my square root is always greater than or equal to 0. It can't be negative because we had a problem right here, for example. 0 is not going to be in my domain because I ended up with a square root of a negative number, which doesn't make sense when we are using the real number system. And again, the easiest way to do this, in my opinion, is I just think, okay, I need 2x minus 1 has to be greater than or equal to 0. I put that thought into an equation. 2x minus 1 has to be greater than or equal to 0. And then I solve for x. So I'm going to add 1 to both sides. And then in this case, I'm going to get rid of my 2. I'm going to divide both sides by 2. Okay, so I'll put this on my number line, and then I'll express it in interval notation. So it's all the numbers greater than or equal to 1/2. So I use the square bracket because it's greater than or equal to. And it's greater than, so I go to the right. And as you can see, that these are all the numbers in between 1/2 and infinity. So my domain is 1/2, comma, infinity. All right, we're going to do one more example. All right, first I'm going to decide, is it a function or not? Now, again, here, it's already solved for y. Again, I'm going to try to plug in numbers. One thing I'm going to start with is I know that I can't plug in x equals 0 because I'll get a negative here. I guess I'll start at 2. Wait, I can't do 2 either. I'm going to start at 3. So let's try x equals 3 just to get a sense of what happens. I get 2 times 3 on the top. I get 3 times 3 minus 6 on the bottom. I get 6 divided by the square root of 3. 9 minus 6 is 3. I'll do one more. X equals 4. That would be 2 times 4 divided by 3 times 4 minus 6. I end up getting 8 divided by the square root of 6. In general, I'm kind of seeing that, when I plug in for this top part, 2 times a number will always give me one specific number. When I plug in for this part here, I'll get one specific number. And when I take the square root of a number, I get one possible number. In no way is it possible for me to get two different numbers for the same x value. So I'm going to say that this is a function. By the way, one thing you can do if you are unsure on this, to be honest, it might be easiest if you have a graphing calculator to just put it in your graphing calculator and use the vertical line test if you really want to double check. All right, let's find the domain. Now here we have an interesting situation. We have two things. Not only do we have a square root, but we also have a fraction. So we need two things to be true. We need that 3x minus 6 has to be greater than or equal to 0. And we need that the square root of 3x minus 6 cannot be equal to 0. We'll deal with the left-hand side first. And the reason we need 3x minus 6 to be greater than or equal to 0 is because that is what's underneath the square root. And the reason we need the square root of 3x minus 6 to be not equal to 0 is because we cannot divide by 0. And so we can't have the denominator, whatever is on the bottom of the fraction, can't be equal to 0. We'll solve the left-hand inequality first. I'm going to add 6 to both sides. And then I'm going to divide by 3. X must be greater than or equal to 2. Oh, we'll do that later. So that's one thing. Let's go on the right-hand side here. We also need that 3x minus 6 can't be equal to 0. So let's solve for 3x equals 0, and we'll know that whatever my solution is cannot be in my domain. I'm going to add 6 to both sides. And I get 3x equals 6, divide by 3, and x is equal to 2. So we know that x can't be equal to 2. So this is a little bit confusing, to be honest, but let's think about it slowly. So what I need, both things to be true. I need x to be greater than or equal to 2, and I need x to be not equal to 2. So x has to be greater than or equal to 2, and it can't be equal to 2. If I combine these two things together, what am I going to get? Well, maybe I'll use the graph just to help us out a little bit. So here's my number line. There's really only one number that I care about. So I need my possible domain could be this, which would be everything including 2, but I also need to skip the number 2, which means that I can't put the square bracket here. I actually need to not include the number 2. So if I put these two ideas together, it's going to be every number greater than 2, not including 2. So in between 2 and infinity. Now, one way to think about this, what is every number that is greater than or equal to 2 that's not equal to 2? Those are all the numbers that are just greater than 2, right? That's really what this is. And expressed in interval notation, that means our domain is going to be 2, infinity. All right, so those are our examples here. I hope you enjoyed the video, and we'll see you in the next one.